Good. This is part one today, and I am just sharing screen. Someone has asked about the Thucical eye. You can tell that my internet isn't the best today because it's taking quite a while to load, unfortunately. I've just gone to LT here and clicked on here to get to the virtual slide, and the AAO is being a bit difficult at the moment. Sometimes, if you try again, it goes faster. It says hopefully. There we go. All right, Thucical eye. So my approach to this is I try and orientate myself so I can see there's probably some bits of ciliary body through here, and there's a hole here that's probably got blood in it. And then the sclera on the outside looks really thickened. And I can't obviously see a cornea, but maybe this is it. And then it looks like we've got one of the ocular muscles attaching here. So here we go, the Thucical eye. Now I can make it full screen, and that might be helpful. Okay, so as I look a bit closer, I can see that there's a whole lot of inflammation. So I'll just go from here. This is the thickened sclera. As we go closer, we can see that there's a whole lot of pigment, and this is from the metaplastic retinal pigment epithelium, which you can see here proliferating. It's just taking a little while to load there. And then in the background here, we've got some chronic inflammation mixed in as well. And the RPE here is undergoing fibroblastic metaplasia and forming this dense collagenous fibrous tissue. All right,
so Diane, where do you think the original layer of the RPE is? Could you take your cursor along
here? I think. Okay. I think this is old choroid.
Yep.
That has got lots and lots of inflammation in it and blood vessels. And I think this is old RPE. And,
right.
You know, there should be a retina up here, but really there's not.
Yep. Got it.
As we move around, we do get some retina, and you can see this RPE line continuing around, looking slightly more normal. This retina, well, it's clearly detached through here because we've got a bit of subretinal exudate. And then as we go closer, we can see that the retina is quite disorganized in places. Here it's like forming these weird little rosetti things, so it'll be damaged, and when retina becomes damaged, it undergoes gliosis. So it's fairly safe to say that there is gliosis. Okay, moving backwards a bit, again we can see the RPE layer as we come around, and then oh look, what's this? This does not look normal. This looks like a penetrating eye injury, right? So this is a foreign body that's in this eye. What is the foreign body? It's kind of brown and looks vaguely like a bit like wood. So I'm going to say that there's a stick there in the eye.
Probably chopping firewood without glasses on and a splinter.
Something like that.
Something like that.
Okay, and then here we've got more Thucical eye and more, this is the original line of the RPE, and more fibrosis. Okay, and then so this is the choroid here, and then here is another area of penetration. Okay, so here you can see a scar through the sclera, and it's going into the vitreous cavity here. So this is so neat. It could be a surgical scar as they try and extract some whatever was in there, but we don't really know. So in summary, I would say this is a Thucical eye with a thickened sclera, hemorrhage, chronic inflammation in the choroid that I can't see any granuloma associated with, massive retinal pigment epithelium proliferation and metaplasia into fibrous tissue. I can't see any bone. And then over here, the remnants of a foreign body. There we go.
Good.
Okay. Good. Was
How
there
long-
anything else? Sorry, Amanda.
How old do you think that that injury occurred? Like, was it last week, last month, last year,
Yeah,
5 years, 10 years?
at least it's last year plus many years,
Mm,
a minimum of a year and perhaps much longer.
Yeah.
Okay, anything else people would like explaining from the homework?
Just on that slide before Diane, sorry, it already stopped sharing, but you mentioned gliosis, and the practice slide also said gliosis. I know you're aware because you've seen it before, but to the untrained eye, how do you know it's gliotic?
Okay,
Yeah.
so anywhere where the retina looks disorganized is going to be gliosis, because the retinal support cells will be proliferating. But if I go back to here,
And just when you're on there, you said the RPE, you showed us how it looked or where the original line could be. But again, if you're looking at this untrained eye, how do you start to look for an RPE layer, which is just, looks like a line of pigment? Yeah.
Stay at low power.
So yeah, second question first. I was going to say you can kind of see it through here.
Yeah.
Okay?
Yep.
At low power. Yep. And so that's going to be choroid and that's going to be RPE. So let's nip into this retina again. So you can see the retina is disorganized because it's forming these weird Rossetti things. Yeah, it's just not doing normal retina things. And then as we come a bit closer and look, it's showing this is gliosis, right? It looks a bit like a cobwebby bit of optic nerve, with all the nerve fibers in it. But what it really is proliferating astrocytic type cells.
Spindly cells.
Yeah, so this in particular is what got spindly, yeah. Okay. All right. Anything else before we carry on for today? Okay. So what I'm going to do now is share my screen again. But the bit that I'm going to share is it says trying to find the right bit, trying to find Chrome.
Okay, so what are we doing? Finishing orbital.
Looking at the schedule.
Yeah.
Yep. So the schedule, we're going to continue doing orbit tumors. Okay. And where we were up to was lacrimal gland neoplasms. So back to here, I'm going to share my screen again. Let's go on to presenter mode. Share slideshow. All right. Okay, so there's only two lacrimal gland neoplasms that a sensible pathology, so ophthalmic registrar needs to know about: the pleomorphic adenoma and the adenoid cystic carcinoma. So because they won't give you weird and wonderful examples of these, they'll give you typical examples of these. The easiest way to tell them apart is probably to look at the stroma, okay? So the stroma looks very loose and myxoid, perhaps with cartilage in for these pleomorphic adenomas. Both of them will have ductular structures, and actually both of them will have myoepithelial cells. But the myoepithelial cells that look a bit like little octopuses in the myxoid stroma will only be present here. And these ones will have a really blue look. And it's very helpful if you can find the very typical cribriform areas. Often you can see basement membrane-like material and kind of mucousy-like material. But better than me actually telling you about it is I'm going to show you a couple of slides, and then you're going to work out what slides they are. So here we go. We're going to go to AAO, which is working better this time. All right, so here's AAO, and we've got this relatively circumscribed tumor. Now, Amanda, what was always step one?
We're looking at low power and we're identifying normal structures. Like, where are we in the body? What?
Right. So normal gland. All right. So that I'm just reminding you of your structure, of your way to think about it. We have normal gland and then we have a tumor. Okay. Even at this low power, I want you to type, I'll just make it a bit bigger.
Yeah,
type in the chat. What do you think this is at low power? At low power, tell me what this is in the chat. That's right. It's a pleomorphic adenoma because you can see how circumscribed it is. Clue number 1. And you can see that there's quite a lot of stroma, isn't there? Yeah.
Blue stroma. Blue.
Yeah. Kind of bluey myxoidy stroma. So what does myxoid mean? It means it's got lots of mucopolysaccharides in it. Just like cartilage. And as we come in, you can see in the stroma are these cells that look like little octopuses. They're actually called stellate cells, but you've got to imagine stars drawn like the old-fashioned star, you know, with the kind of things going out. So they don't look like flaming balls of hot gas.
They've got very spindly extensions.
Yeah, they have. Yep.
Yes.
Okay. And when we look here, we can see that we've got ducts and they've got pink stuff in them. Yeah. Pink secretions. And they've always got 2 quite easily identifiable cell layers, the epithelial and the myoepithelial cells.
Which way around do they go? Which is the one on the inside of the lumen?
The epithelial cells.
Mm-hmm.
Myoepithelial cells are on the outside. And then
can we compare to a normal duct?
Yeah, let's see if we can compare it to a normal duct, because we do have normal here. Excuse my internet. There's no one even like streaming Netflix or anything. We're all just like off the computer and it's like this. Oh, come on, AO.
You had to ban the rest of the family from using the internet.
Yeah, I do. Yeah.
Okay, good.
All right, here we go. So this is a normal duct here. Now, the myoepithelial cells aren't as prominent in normal ducts, okay? So these are acini, these are ducts, right? Yeah. But you can cut, so that's a myoepithelial cell here, and that's a myoepithelial cell, and these are all the epithelial cells. And so there are 2 layers, but they aren't quite as prominent as the ones in the tumor. I should have taken you to a big duct.
Yeah, big ducts are easier, aren't they?
Yeah.
But we can look at that when we look at our individual cases too.
You can, yeah. Okay. So using escape, I will go back to here. So we've got here, so where is the normal tissue? Oh, normal tissue is here. This is the eyelid, okay, or the skin. Probably the eyelid because here's the orbicularis muscle. And then here we've got something happening, and that's the remnants of the normal lacrimal gland here. And then beside it, we've got blue stuff, all right? So here we don't have that stellate myxoid stroma. We've got cells that are pretty uniform looking.
Shall we ask them what they think?
Yeah, we can see it's got 2 cell layers in some ducts. Okay, so what's this one?
Yeah, but at the top, 12 o'clock has got the best architecture, doesn't it?
Yeah. All right, so you all think it's adenoid cystic. That's good. Yeah. So this is the best architecture here, where you can see the cribriform or lotus root type appearance. Yeah. And then when people talk about 2 types of things in the ducts, this is the basement membrane material that they talk about. And then you get this looser kind of mucousy kind of thing that here and here.
They look different colours to me.
Yeah, but the key thing is they are different colors. Yeah, at low power, this is infiltrative. Yep.
Do you think
And
the surgeon's got it all out? Should we ask the team?
all
What
right.
do you,
Okay.
yeah,
Has the surgeon got this all out?
you're the surgeon. Have you got it all out?
No, because it's really here at this blue inked margin, isn't it?
Yeah, it's not all out.
This will recur.
Is that typical?
Time. That is
Typical
very
of that?
typical.
Yeah.
Hard to get it out. And when you think you've got it out, you find nerves. So here's some perineural invasion. I spotted it at low power because I looked for the concentric whirl, right? And in the middle of it was a nerve, and this is the perineural invasion. And those cells will creep a long way away. And in 20 years, there'll be a recurrence somewhere in the neck.
I can see that concentric really well at that power.
Yeah. Okay, so your turn here. So, oops, that was the wrong thing. Come on, no, we aren't going to that one. We're going to this one. Have you all got this up? I am just trying to put it in the chat. Okay, so everyone can open this. Everyone, please open that, and I will now put you in your breakout groups. But while I'm fiddling with the computer, can you please?
Do you want us to open
any
one or both of those?
It's actually a good idea probably to open both and have a look, isn't it?
Okay. Yep. And we can have the driver can have both side by side. Yeah. Okay.
Yeah.
All right.
Good idea.
Yeah.
So the next one is this one here.
So we're going to open those two bottom path presenter cases. Is that right?
Yeah, that's right, which I'll also put in the chat.
So the driver has two up on screen side by side, and then share your whole desktop view. So sharing both windows. Okay,
there we go. There are the two slides. How many people have we got today? We've got 4 teachers and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. So I'll make 6 groups. Okay, we'll move between them. But please keep asking questions about how you tell the difference between them. This is...
Or type in the chat.
Your chance.
Is always a good way to share.
Okay. I'm just moving people around so that we have.
And then we'll stop share. Yeah. And
yeah.
Otherwise it'll be a big gap. Till we come back.
Oh, you mean stop recording? Pause recording.
Oh, that's right. Yeah. Pause record.
Okay.
Amanda, the one thing you might just want to talk about is the molecular differences between testing differences between PAs and adenoid cystics.
Yes, that is a very good point to make. And I just want to share the right screen if I can. Share screen.
Oh, I never do that. I just do it by eyeball. I'll learn something.
Screen sharing.
Usually it's not a problem, but when you've got a difficult case, it can be useful.
Yeah, yeah.
I can't see what I'm screen sharing. Am I screen sharing the right thing?
I can see your screen. You've got a nice side by side there.
I do. Okay. I just don't see that green rectangle thing around the outside. Okay. All right. Drive me, Diane.
Right. So just at low power here, I noticed that on the left-hand side, we've got a very circumscribed tumor in a gland. And then on the right-hand side, we've got a very infiltrative tumor. I wonder if you can go perhaps down to the smaller nodule in the left-hand one, which I think is going to be a pleomorphic adenoma because of its circumscription.
Circumscribed, very blue looking, isn't it? What's our normal tissue? So
the normal tissue to the left is actually salivary glands, because I chose this one because of the great stroma. And then to the right-hand side of that, we've got the bluey kind of stroma, but also the bright pink epithelial cells. Okay, so can we just, right at the edge of the left-hand edge of the
Tumor.
thing,
Yeah.
tumor, we've got some nice ducts and some nice stroma. Can we zoom in there, please?
Stroma and epithelial components.
Yeah, so you can see there we've got the bluey stroma, which is actually very myxoid. So think kind of loose, bit like snot, that kind of look. And then
hyaluronic acid, that sort of thing.
yeah, that kind of thing. And then the ducts, which are round and have lined by epithelial cells. Now, quite a few of these groups are solid, but that's mainly because they're mostly myoepithelial cells and they haven't formed many ducts.
So pleomorphic adenomas, I thought pleomorphic meant malignant.
Yeah, it's because they were named in the good old days. Pleomorphic means varying. So when cells are pleomorphic, they vary from one another, but pleomorphic adenomas vary from one place to another. And we're seeing it in that field there, where with some bits with lots and lots of stroma and other bits with lots and lots of epithelial cells. So if we were naming it today, we probably wouldn't do this. We'd call it a benign mixed tumor, wouldn't we? Like we do in other areas of the body. Yes. Because it is benign and it is a mix of epithelial and myoepithelial cells.
That's right. And I like these floating individual myoepithelial cells. They're floating in the stroma. Quite often you see that, don't you? They're floating.
You do, yeah. So where does the matrix come from, Amanda?
Well, I thought it would be these little fellows here who are making them.
Yeah, it's secreted.
Stromal cells.
Yeah. And often in the 5 questions, you ask for the normal, the abnormal, which we've just described, a pleomorphic adenoma with myxoid stroma and benign ducts, and the prognostic factors. So this is benign, so it has a good prognosis, but the prognostic factors are that it is completely excised and that there's no evidence of atypia, mitoses, or malignancy, because very occasionally, only like textbook rarity, occasionally can you sometimes get tumors arising in these, which are adenocarcinomas, mostly if they're left behind and are there a very, very long time.
What are they called? Should we ask the team? When a pleomorphic adenoma goes bad, what's it called? Type in the chat. Now I can't see the chat anymore. So.
I can see the chat.
Okay. It's pleomorphic adenoma.
Adenocarcinoma X pleomorphic adenoma.
Yeah. Okay, that's right.
Out of it. Yeah, it comes out of it.
Yeah.
Okay. Great. Should we look at the next one?
Yeah, we should. Now, this was interesting about, first of all, determining the normal tissue type. So, because we were a little... we've got another, and this very infiltrative tumor. Infiltrating, yeah.
Yeah, there's some fat, isn't there? Yep. And there's some ink on the fat.
That's normal tissue, the fat.
So,
and over this side, there looks to be an epithelial plane.
We can see a pathologist on the left hand for a minute.
Here we go. Hopefully you can see
on the left hand side.
Yep. So I see an epithelial surface here. This is not malignant. It looks normal to me. But oh, Diane's frozen. So are you still there? Diane's audio is not so good.
Okay, so we've got a tumor.
There's a lag. Shall I speak?
Plotting an epithelial surface, haven't we? And then infiltrating something.
Yeah.
Oh, okay. You talk then, Amanda.
Okay. Yeah, Diane keeps on breaking up. So this is squamous epithelium, multiple layers, squamous cells. So squamous epithelium can occur in mucosa and in skin. How do we tell the difference? Is there any hair follicles here? There are no hair follicles. Therefore, I think this is a mucosa. And we know that adenoid cystic carcinomas can occur in various sites around the body. This example that we've given you here is not necessarily from the eye. So squamous epithelium here, it's occurred in a mucosa, and therefore there would have been a gland underneath the mucosa, deep to the mucosa, from which this tumor has arisen. So this is how I'm approaching this tissue. So it's a squamous mucosa, and we know there's squamous mucosas all over our body, including oral, genital, respiratory, lots of different mucosas.
So Amanda, when we're often describing tumours, we describe the grade, don't we?
We do.
What things do we look at when we grade adenoid cystic carcinomas?
Well, common things would be things like a mitotic index that applies to a lot of tumours. But adenoid cystic carcinomas, we could look at some architectural features.
The growth pattern. So if an adenoid cystic carcinoma is low grade, it forms little round duct-like structures, and the grade 2 ones, they form cribriform areas, and then the grade 3 ones are solid without any cribriform areas. So everybody who's looking at this, tell me what grade this is in the chat. Yeah, everyone's saying grade 2 because they can see the cribriform areas. Right, so other prognostic features are whether or not the tumor is completely excised and whether or not there is perineural invasion.
So I'm going to have a look for nerves. Oh, and also, can you tell us a bit more? Oh, I see some concentric things here. 1, 2, 3. Spot them at low power. And it looks like there's a pink thing in the middle, which looks like a nerve to me. So I'm just going to go a little closer. That's an artery. This is a nerve. See, it's got spindled cells running this way. And that's a perineural invasion. And it's at the advancing edge of the tumor. So I think the next stop for this is the patient. So that's another perineural invasion, this crescentic shaped thing, another nerve. Here's another one. Spot it now. Wavy spindled cells. That's a nerve.
Yep. So lots of perineural invasion here. And then there's the stage. So we don't expect you to know all the staging systems, but just note that it extends into fat. Is it present at a margin?
I don't see any ink, so I'm not certain that a margin is representative in this piece of tissue.
There's a bit off to the right.
Oh, is there?
Over
the other side. Oh, yes, there is here. So, okay, so I'm looking at the black ink here. Oh, I'm a bit suspicious. Ooh.
Yeah, up there it looks a bit dodgy, doesn't it? So there it is.
Yeah,
probably at a margin.
Probably at a margin.
Some muscle. Yeah,
less than 1 millimeter. Could you just tell us again about, like, there's this blue myxoid stuff within the cribriform spaces. So how is that different over here in the pleomorphic adenoma? We have this extracellular blue stuff, and here we have blue mucin-like material within the duct lumen. It's a bit confusing.
It is a bit confusing. So the epithelial cells produce mucus, which has got lots of polysaccharides in and looks blue. And myoepithelial cells produce lots of myxoid stroma, which has got polysaccharides in and looks blue. So the color just tells us what it's made of, not where it's come from.
Yeah. So we can see there are similarities and differences.
Okay. So Bridget, do you want to tell us about the molecular things? So if we've got, I presume, cytology and it's only got 6 cells on it, but there's enough to get some next generation sequencing out, what do we look for?
So it's really good if you've got a small sample source, so cytology, or if you've got a really small biopsy of one of these tumors and you can't really tell the difference. So for pleomorphic adenomas, we can either use immunohistochemistry, which checks for that translocation and that we're looking for PLAG. And for adenoid cystic carcinomas, we're looking for the MIB translocation, and that we send off for FISH for MIB. So you can do FISH or immunohistochemistry for pleomorphic adenomas, or you can do FISH for MIB for adenoid cystics.
Great. Okay, we've got one last slide to look at in this orbital thing, and I'll put it in the chat again.
Oh, Bridget,
And
and
then-
also if you want to elaborate a little bit in the chat about the MIB for ACC. Stop share.
You can't come over here. Rita, you can't. Rita, you have to go out. Rita, you have to go out.
Sandy, you need to mute.
Oh, sorry.
But lovely to see your family.
Yes.
Okay, so I'm going to put people in. So can everyone please click on the link to open up the next slide? And we will go into breakout groups. I'm going to do the same breakout rooms. But before I do, I'm going to make Amanda a co-host so that she can move around too.
Mm-hmm. Mm.
Okay, off we go. Are you? Oh, good. resume the recording. Off we go.
Yep.
Thank you. Resuming the recording. Yay.
Yay. Should I share?
Yeah. Because
Um,
suddenly freeze, you can just take over.
am I sharing properly? I can't see the
Yeah,
green
that's
thing
good.
anymore.
Yeah.
Okay.
So at low power, we've got there's no normal tissue except for a little bit of fat, but we've got this dark blue tissue which has got lots of round pink dots in it. So we've got to think, what causes round pink dots? Well, pink is often associated with epithelial cells and epithelioid cells, and they're pink because they've got lots of cytoplasm.
Mhm.
So Amanda, can you go maybe at the top? There's a bit that doesn't have quite so much pink in it, but lots of round dots in it.
Okay, so just some separated, some background non-pink areas is what you want, yeah?
I do, looking for the background non-pink areas. So if we look in the background non-pink areas, you can see the ducts
Okay,
eventually when it clears up, and then around them are little blue cells, which are inflammatory cells. But where have all the acini gone? This is a destructive lesion. The
so you're saying we must be in the lacrimal gland, if this is
I
the
think
orbit?
we're in the orbit and the lacrimal gland. Yeah, we're in a gland with all the ducts. Yeah. And the ducts are being destroyed by the inflammation. So now we can see that these balls, these pink balls, are existing within this background sea of lymphocytes and ducts, and the acini have gone. The balls are fairly round, you know, they're not jaggedy, they're nice and round, a bit like tiny little cannonballs, golf balls. And some of them have got giant cells in the middle, and there's a beautiful giant cell that Amanda.
Isn't that magnificent?
The giant cells are where the epithelioid cells have all decided to melt together. So all the nuclei that were just one in each individual cell. In fact, that one looks like it's got 50 nuclei. So 50 epithelioid cells have all joined together here.
So would we just call this a multinucleated giant cell?
We would.
Yeah,
okay. Multinucleated giant cell. Now, of course, you from your reading, you'll have realized that we classify granulomas often into necrotizing and non-necrotizing, and this doesn't have necrosis in it.
Before we go there, can you explain to me, these epithelioid cells out here, are they really the same as the giant cells? How are they the same or the different?
They really are the same. So they're all part of the monocyte lineage. Remember the monocytes? They circulate around in the blood, and then they pop into tissue and start doing their histiocyte-like actions and secreting cytokines. And then they can turn into macrophages and chomp things up. And then they can join together and form giant cells, which are like much more inactive.
So these mononuclear cells, they have really, their nuclei look very characteristic to me. They don't look round like a typical epithelial cell. They're rather
kidney shaped, classically. Yes.
Elongated, kidney shaped. So these are our epithelioid histiocytes to make up the
just
granuloma.
Like melanoma cells, we call some of them epithelioid as well. They aren't actually epithelial. They're epithelioid because they've got lots of pink cytoplasm, like epithelial cells, but they're still that monocyte macrophage lineage.
Okay, so these are epithelioid histiocytes plus giant cells equals granuloma. Is that correct?
Well, you don't have to have giant cells. So even the little granuloma that is doesn't have a giant cell in the middle of it is still a granuloma.
Okay.
So granuloma is defined as a collection of epithelioid histiocytes.
That looks like a collection to me.
Yep. And if you think of the little granulomas forming the Dahl and Fuchs nodules, say in sympathetic ophthalmitis, then they don't have giant cells with them. They're just little collections of epithelioid histiocytes.
Yep. And typically they're surrounded by chronic inflammation.
Okay, so this is
so you were telling us
non-necrotizing people.
Type in the chat, what did you see? And I'll see if I can search around and find some. So the ones that we looked at so far, non-necrotizing.
Yeah.
Well, what about over here?
It is definitely non-caseating. So caseation is a subcategory of necrosis. So you can have caseating necrosis and non-caseating necrosis. So there, it's looking very degenerate in the middle there, isn't it? So sometimes you get breakdown in the middle of these sarcoid-like granulomas. In fact, about 10% of them will have this central breakdown. This doesn't necessarily mean that we're thinking of TB here, because the majority of them aren't. So you can't actually definitively call a disease depending on just what 1 or 2 granulomas look like. And so we would always correlate this with the clinical situation of the patient.
So I was explaining to people in my group that when we think of granulomatous inflammation, to go down that diagnostic decision tree about necrotizing versus non-necrotizing, not just to jump to granulomas equals sarcoid.
Yeah. Okay, I think that's the end of that.
I think
section.
Diane, would they also need to rule out the other possibilities like tuberculosis, ZN, PAS, foreign body in the answers?
So so if we were writing a differential diagnosis here, probably the clinical differential diagnosis and then the pathological differential diagnosis would be quite good to write about. So the clinical diagnosis differential would be in particular be things like lymphoma and Sjogren's syndrome. And the pathological differential diagnosis would be other things that cause granulomatous inflammation. It's going to be so incredibly rare to get TB in the lacrimal gland, but maybe some people with Crohn's disease might get some lacrimal gland granulomas. And then in order to sort it out, I would recommend not doing a raft of stains, but doing some clinical correlation. So if the person's got known sarcoidosis and it looks like this, then you're going to call it sarcoidosis.
Okay, stop share.
Okay, good. All right, should we take a 5-minute break now?
I think a break is about time. So
right.
Back at, give us a time, 2:20?
So 2:20, 2:20. Go
Okay.
get a cup of tea or something.
Get up and walk around.
Yep.